Hello everyone and welcome. Today I'll be talking about electrical safety at home, mainly talking about electric shocks, what causes electric shocks, how to prevent them, and I'll also be talking about what are some factors that affect the severity of an electric shock. So let's get into it. Like we all know, electricity is very important for our daily needs. It makes our lives easier, charging our phones, powering our devices, but at the same time, if handled carelessly, it can lead to very serious injuries, fire, or even death. So the question is, what is an electric shock? An electric shock is what happens when electric current flows through the human body. And the factors affecting the severity of an electric shock: the first, the amount of current that went through the victim's body, which is also known as the amperage. Second, the person's body resistance at the time the electric shock happened. Third, the current path. Fourth, the duration of the shock. Now, I'm going to talk about current versus voltage. There's always a very common question that people ask: between current and voltage, which kills? And a lot of the times people always say current, but I'm here to explain that. I'm here to explain why that is not entirely true, because they both play a part. For instance, let me explain using the water analogy. Let's use voltage represents the pressure and current represents the flow of the water. So what happens is, if the pressure is high, more water is going to flow through that tap in a predefined period of time. But if the pressure is less water is going to flow in that same amount of time. And the same applies for current. If we have very high voltage, in a short period of time, more current can flow. But if the voltage is lower, in that same amount of time, less current is going to flow. So what is really dangerous, it is the amperage, which is the amount of current that flow through the victim's body. Also, it is important for us to know that we have two main types of current. We have the direct current and we have the alternating current. The direct current is what we mostly find in the batteries, in our phones, in our laptops, and alternating current is what we find in our homes, used to power our homes and offices and all that. And it is also important to know that AC is more dangerous because it causes the muscles to contract uncontrollably, making it hard for the person to let go. And that explains why once someone is having an electric shock, the person can't let go of what he is holding. Another very important aspect is the body resistance. A lot of people don't talk about the body resistance, but it is very important because our natural body, dry skin, has body resistance of approximately 70,000 to 100,000 ohms. But in the case where your body is wet, or you are in a humid environment where you are sweaty, the body resistance drops to approximately 1,000 ohms or less. And you can see from the Ohm's law equation on the left, current is equals to the voltage divided by the resistance. So the higher the resistance, the less current is going to flow, but the lower the resistance, then more current is definitely going to flow. So when your body resistance drops drastically, it increases the severity of an electric shock. So the next is the current path. The current path the current takes through your body can determine the severity of the electric shock. And like we all know, or like we usually say, electricity always takes the path with the least resistance through the body. If the current passes through the vital organs like the heart, the lungs, the danger is very high. Like in this example, I listed three different examples. The first is hand to foot. In this scenario, current flows from your hand through your chest, which makes it difficult because your heart is in your chest, through your belly, where you have your lungs and other organs down to your foot. This case is very dangerous because current might potentially damage all of those vital organs. The second is hand to hand. This is where current flows from your one hand through your chest to the other hand. This is also dangerous because current flows through your chest, which might potentially harm your heart. And the next is head to foot. This one is extremely dangerous because current flows through your head, where your brain is, through your chest, where your heart and your lung is, and through your belly, which you have other organs there, down to your foot. So, with the part in which current took to flow through the victim's body can also determine the severity of the accident. Next is the duration of the contact. The longer you're exposed to electricity, the more dangerous or fatal it is. So, person who's exposed for just 1 second and person who's exposed for more than 3 minutes, it's going to be very different. So, as you can see, 0 to 1 second current just enters the body. We have a mild tingling, shock, muscles may react, but still very low risk level. 1 to 5 seconds, current affects the muscles, cause a painful shock, muscle control loss, and it is also hard to let go. And the third, 5 to 30 seconds, this is where it now affects the breathing. Breathing becomes difficult and also have a risk of respiratory paralysis. Then, 30 seconds to 3 minutes, current affects the heart. Now, this is where I have a high risk of a ventricular fibrillation, which health professionals call a VFib, and also internal burns. It is very, very dangerous and life-threatening. And for more than 3 minutes, we have a risk of cardiac arrest, and also death might occur. Now, the causes of electric shock at home. The first, we have damaged wires and damaged insulation. This is very common because we have a lot of people see damaged wires in their homes and they don't take the precaution to change or fix them, which is very dangerous. The next is unprotected socket outlets. It is very important to have socket outlets with switches on them, especially if we have kids at home, and always make sure the sockets are off if they are not in use. And it is very risky if not having those because children like to input a lot of things into socket outlets. So unprotected socket outlet, it's another cause. Then we have wet hands and environments. Like we talked before in one of the previous slides, the body resistance is greatly affected by the environment and the state of your body. If your body is wet, your body resistance drops drastically. Or even if the environment is wet, your body resistance drops drastically. And again, we should also note that water is a conductor. So just because of that water, current might flow through your body. Then the next is faulty earthing. Faulty earthing or no earthing at all. A lot of people don't have earthing in their homes. So in case you have failed insulation inside an electrical appliance, you touch the body, you might get shocked. And the next is unsafe DIY repairs. DIY actually stands for do it yourself. So we shouldn't attempt to fix electrical appliances at home. And I'm going to give a special note on microwaves because I know a lot of people who were shocked trying to repair microwaves, and unfortunately for them, they lost their lives. Microwaves have very high voltage inside of them, so trying to fix them while they are on power can be extremely lethal. Remember when we talk about Ohm's law, I said the higher the amount of voltage, the higher the amount of current that can flow through your body. And again, when it comes to microwaves, even if they are not powered, microwaves had a lot of capacitors in them that if you try attempting to fix them, that you did not properly discharge those capacitors, you have a very high risk of getting severely shocked. Now, how to avoid electric shocks at home. The first, inspect broken cables and repair them regularly. This is very important. Check if you have any broken wires, just replace them because it might lead to electric shock. Install RCD protection. RCD is known as residual current devices. These are circuit breakers that are designed to trip if there is any leakage of current. So if you touch a device and the RCCB, which is a residual current circuit breaker, is going to know that there's current leakage because current is going to flow through your body and not through the normal circuit, and which is going to prompt the RCCB to trip. This is very important. We need to make sure we have them installed in our homes. And keep water away. Keep water away from any electrical appliance. If you see water close to any electrical appliance at home, turn off that appliance and clean the water. And also, if your hand is wet or the environment is wet, avoid touching any electrical appliance. The fourth, we should also make sure we have proper earthing system, earthing or grounding system, because if you have failed installation in any electrical appliance and each device is earthed, that leakage current is going to flow to the ground and it is not going to shock you. And it is also important for us to know our limit. It is always written in electrical appliances, only certified professionals only. If you are not a certified professional, do not attempt to fix any electrical appliance at home because it can become very fatal. And again, emergency response. In case you find someone who is being electrocuted, the first thing you need to do is do not touch the victim. That is very important because your body can also conduct electricity. If you touch the person, you could become the next victim. So the first thing to do is to cut the power supply as soon as possible. If it is not possible for you to cut the power supply, you need to look for a way to separate the victim from the shock. You remember when we talk about electric shock in one of the previous slides, we mentioned that while you are shocked, your muscles contract, making it difficult for you to let go. So in this case, you need to use a clean, dry, non-conducting object like a wooden broom, a chair, to push the person away from the source, or push the wire away from them. Or if they are touching a device, maybe a refrigerator or a TV, and they get shocked, if it is accessible and it is safe, you can turn off that device, like plug out that device, and it's going to stop the electric shock on that person. The next is call emergency help. Call your local emergency help immediately and tell them the situation. Then the fourth, while waiting for your emergency to come, if the person is unconscious, you can start doing CPR if you are trained. But if you are not trained, just try to put the person in a position where the person can breathe properly. And the next, you get professional help, and that is it. So in conclusion, electrical safety awareness saves lives, and it is important for us to follow all precautions at home and keep ourselves and our families safe. Thank you.